Hello friends and my dear students, I welcome you all to my channel. This is set 3 of 10 good problems on the chapter of factorization. This video is part of the playlist Maths 8 Hot HOT. HOT stands for High Order Thinking Problem, where I prepare and solve 10 good problems from each chapter as and when they are completed in the other playlist CBSC Maths 8 RS Agarwal. So if you are new to my channel or not yet subscribed, or if you are watching my videos for the first time and my videos are beneficial to you, then I strongly request you to please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 10 good problems of set 3 on the chapter of factorization. Okay, so I have the 10 good problems on the left hand side. I hope you can read the problems. The fonts are big enough uh, so that you can see it properly. The link of the PDF of these 10 good problems will be given in the description below. You can also check the PDF from that link. On the right hand side, I will solve the problems. So while solving the problems, I will pause for, after solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will be beneficial to you. Okay, so let's start solving the problem. The first problem says that if the polynomials or two polynomials are given, if the polynomials are divided by x minus 3, then the remainder in each case is the same. Then the value of p is. So both the polynomial, as we can see, are having an unknown constant. P is a constant, but it is unknown. We have to find that. The first polynomial is pxs cube plus 4x square plus 8x minus 4, and the second polynomial is x cube minus 4x plus p, and it is said that when we divide this polynomial by x minus 3 then the remainder in each case is the same. Now, since p is an unknown, we cannot really do the division of the given polynomials by x minus 3 because p is unknown. We do not know the value of p. For doing a division of two polynomials, we need to know exactly the two polynomials. Then only we can perform the long division method. But there is another concept that you must. It is not yet will be taught in your in class 8. But there is a concept you might be taught in higher classes like class 9, 10, or class 11 and 12. You will be definitely taught. It is that if a polynomial, the concept is, let's say, if a polynomial p, let's say p is some polynomial of some degree. A polynomial p is divisible by, let's say, is divisible by x plus a if value of p at x equals to minus a, y minus a, because whatever this x plus a is, you have to solve that x plus a equals to 0, and whatever value you get for x will be minus a. If you compute the value of the polynomial p at x equals to minus a, then the value will be 0. This implies that x plus a will be a factor of the polynomial p. So a polynomial p, it can be of any degree. Definitely it is higher degree than the x plus a. X plus a is a binomial of degree 1. So a polynomial p will be divisible by x plus a if the value of the polynomial at x equals to minus a. Now how come minus a is coming? Because if you solve x plus a the divisor x plus a equals to 0, whatever value you get of x, that value, if at that value the polynomial is becoming 0, then we can say that x plus a is a factor of the polynomial p. Also, uh, another concept is that the remainder the remainder the remainder when p, that is p is the polynomial, is divided, the remainder when p is divided by x plus a, where a is a constant, is a value of p at x equals to minus a. If it was x minus a, then it would have been x equals to a. So if you put, so whatever the divisor is, in this case we are considering x plus a. If you equate that divisor to 0, whatever value you are getting for x, that value, if you put that value as x in the polynomial, if you get 0, then x plus a will be, then the polynomial will be exactly divisible by x plus a. And if you do not get 0, then whatever value you are getting, that will be the remainder of the polynomial p when divided by x plus a. Now back to the question. So we can say that, so it is given that these two polynomial are, when divided by x minus 3, it gives the same remainder. So we can say that remainder of, let's say, this polynomial, let's say we call it, instead of writing again and again the first polynomial, let's call it p1, and let's say this polynomial, call it p2. So remainder p2. So remainder when p1 is divided by x minus 3 is equal to value of p1 at x equals to minus x equals to 3. Why equals to 3? Because if you equate x minus 3 equals to 0, you will get the value of x as 3. So remainder when p1 is divided by x minus 3, it will be the value of p1, that is a polynomial, at x equals to 3, which is equal to, if you substitute the value of x as 3 in the polynomial, it becomes p into 3 cube plus 4 into 3 square plus 8 into 3 minus 4. So this is equal to 27 p plus 4 into 9, 36, plus 24 minus 4. This is equal to 27 p plus 56. This is the remainder when the first polynomial is divided by x minus 3. Similarly, we can say remainder when the second polynomial, that is p2, is divided by x minus 3 is equal to value of the polynomial 2, that is the second polynomial, at x equals to 3. This is equal to, we will just put the value of x as 3 in the second polynomial, and it becomes 3 cube minus 4 into 3 plus p. So this is equal to 27 minus 12 plus p, and this is equal to 15 plus p. It is given that both the remainders are same. So we can say that 27 p plus 56 is equal to 15 plus p. So this implies, this becomes a linear equation in the unknown p, And if we solve for p, we get, if we bring all the p terms to the left hand side and all the constant to the right hand side, we get 27 p minus p is equal to 15 minus 56, which is equal to 30 minus 30, how much is this? Minus 41. This implies 26 p is equal to minus 41. Minus 41. It is not dividing properly. We are getting p is equal to minus 41 by 26. No, it is not dividing properly. Let me see if I have done it correctly or not. The value of the remainder when the first polynomial is divided by x minus 3 will be the value of the polynomial at x equals to 3. So we have pxs cube plus 4x square plus 8x minus 4. So we have p into 3 cube plus 4 into 3 square plus 8 into 3 minus 4. So we have 27p plus 9, 36 plus 24 minus 4, 20, so 56, 27p plus 56, and remainder when p2 is divided by x minus 3 is the value of the p2, that is the second polynomial, its value at x equals to 3. So this becomes 3 cube minus 4 into 3 plus p, and we have 27 minus 12 plus p, which is equal to 15 plus p. So we have 27p plus 56 is equal to 15 plus p, and hence we get 27 minus p equals to 15 minus 56, which is minus 41. No, in the remainder case is the same, then the value of p is I'm not sure the values of in my solution the value of p is not coming to be an integer, it is coming to be a fraction, it is not dividing properly. I'm putting a question mark. I will come back to this question. Maybe I have done something wrong in writing the problem. That could be a possibility. If that is the case, I'm really sorry for that. So let's skip this question. I will come back to this question later on. Let's do problem number 2. What must be added to a polynomial is given. What must be added to this polynomial to obtain a polynomial which is exactly divisible by x minus 1 into x plus 3. So we are asked to find the algebraic expression which must be added to the given polynomial which is of degree 4, so that after adding the expression the polynomial will be exactly divisible by x minus 1 and x plus 3. Now it is exactly divisible by x minus 1 into x plus 3. It does not mean that it will be equal to x minus 1 into x plus 3. It just means that x minus 1, the product of x minus 1 and x plus 3, whatever that polynomial is, that polynomial will be a factor of the given polynomial, that is the polynomial of degree 4. Now what must be added to it? So the polynomial is x to the power 4 plus 2x cube minus 2x square minus 2x minus 1. Certainly this will not be factorized such that it will have the factors x minus 1 and x plus 3, because we have to add something. We have to add something. Only then, after adding some expression, only then it will be a, it will have the factors x minus 1 and x plus 3. Now, what must be added? How do we know? Uh, if we try to divide the given polynomial by x minus 1 multiplied by x plus 3, we will get some quotient and remainder. We will get some quotient but and remainder. Uh, from that remainder, possibly we can see what can be added so that it will be exactly divisible by x square, x minus 1, and the product of x minus 1 and x plus 3. Now, what is x minus 1 multiplied by x plus 3? This is equal to x square plus, you must be familiar that x plus a, product of x plus a and x plus b is equal to x square plus a plus b into x plus ab. So this will be x minus 1 multiplied by x plus 3 will be 3x square plus 3 plus minus 1 x minus 3. This is equal to x square plus 2x minus 3. So this will be a factor of the given polynomial after we add some algebraic expression to the given polynomial, and that algebraic expression we have to find. Now, if we try to divide, let's see here. Let's do. So this is the dividend. This is the dividend. This is the dividend, and this is the divisor. Let's do long division and see. Definitely, it will not divide exactly. We will have some remainder, and seeing the remainder, we might be able to figure it out what can be added to the remainder so that it gets exactly divisible by x square plus 2x minus 3. So we have to perform long division method. So what will be the first term of the question of the long division method? That is the first term of question of first term of the question will be equal to the first term of the dividend divided by the first term of the divisor. So this is equal to x square. So if we start dividing the given polynomial by x square plus 2x minus 3, this will become a little lengthy calculation. I'm not sure if there is any other smart way of solving this. I will figure that out later on, but as of now, let's do it by long division method. So I am doing the division, and the first term of the question will be x square. So then I will find the product of the first term with the divisor and subtract that from the dividend. So the product of x square and the divisor is x to the power 4 plus 2x cube minus 3x square. I will subtract this from the dividend, and I will get minus plus. So x to the power 4 cancels out, 2x to the power cube cancels out, and I get x square. Now I will bring the next term added to the remainder, and this becomes the new dividend. This becomes the new dividend. Now the next term of the question will be the first term of the new dividend, that is x square, divided by the first term of the divisor, x square. It is 1. So the next term will be x square plus 1. Now 1 multiplied by the divisor is x square plus 2x minus 3. We have to subtract this. So minus plus, x square cancels out. We have minus 4x. We have minus 4x, and we have minus 4x plus 3. Minus 4x plus 3. Okay. Now we will bring down the next term and add it to the remainder, which becomes minus 1. So this is equal to minus 4x plus 2. This is the remainder. This is the remainder, final remainder. Now we cannot do any, we cannot proceed with the long division method further because the divisor is having a higher degree than the remainder. Now we have to see what. So now the question is, what can we add to this expression? What can we add? Let's say let's say we want to add a y, so that this expression, the expression that we need to add is y, so that minus 4x plus 2y plus 2 plus y will be divisible by x square, will be divisible by the divisor, that is x square plus 2x minus 3. Uh, oh, sorry, no, it's okay. X square minus 2x plus 1. So x square plus 2x minus 3 minus 4x plus 3. So what can we add? What can y be, so that this expression minus 4x plus 2 plus y will be exactly divisible by x, the divisor, that is x square plus 2x minus 3. Okay, what we can do one thing. If somehow this remainder, if somehow this whole expression, if somehow this whole expression becomes 0, because minus 4x plus 2 was the final remainder. Now if we add y to the whole polynomial, then the final remainder will be minus 4x plus 2 plus y. Now if somehow this whole remainder becomes 0, then the remainder will be 0, and we can say that the divisor x square plus 2x minus 3, which is essentially x minus 1 multiplied by x plus 3, will exactly divide the given polynomial. So if we say minus 4x plus 2 plus y equals to 0, this will imply, we can say that y will be equal to, we have to bring these two terms on the right hand side, we get 4x minus 2. So if y is 4x minus 2, that is, if we add 4x minus 2 to the whole given polynomial, then if we perform the long division method, there will be finally the remainder will be 0. Finally the remainder will be 0. So we can say that this can be the expression that need to be added to the given polynomial, so that it will be exactly divisible by x minus 1, the product of x minus 1 and x plus 3. So the correct choice is D. D is the correct choice. Okay, let's do problem number 3. Okay, the rational expression in its lowest form is, okay, so a rational expression means we know that a rational term is basically a rational term. You have already learned the rational numbers, which is of the form p by q, where p and q are integers and q is not equals to 0. In general, a rational term is like p by q, where p and q are numbers or algebraic expression or algebraic expressions, and definitely q is not equals to 0. So the given rational expression is xs cube minus 3x square plus 2x divided by x square y minus 2xy. It is asking to reduce this rational expression or rational expression. So it is using the term rational expression. Why? Because the numerator and the denominator are both algebraic expression. That is why it is referring as rational expression. So it is asking to reduce this rational expression to its lowest term. We know that in rational numbers, we convert a rational number in its simplest form, like 6 by 4 is a rational number, but it is not in its simplest form. The simplest form will be 3 by 2. Similarly, it is possible to reduce a rational expression in its simplest form. How? By cancelling out common factors from the numerator and the denominator. So we have to factorize both the algebraic expressions in the numerator and the denominator and cancel out the common factors from them. So from the numerator, you can see we are having a common term x from all the terms. So if I take out x as common factor from all the terms in the numerator, I get x multiplied by x square. My handwriting is not coming good. Okay, so minus 3x plus 2, and from the denominator I can take out xy as a common factor. So I get x minus 2. Okay, now this is equal to, now x cancels out. Now we can further factorize x square. So this becomes x square minus 3x plus 2 divided by y into x minus 2. Now we have to see whether we can factorize the numerator further. That is x square minus, let's try to factorize x square minus 3x plus 2. So this is a quadratic trinomial, and we have to find the two numbers a and b such that a plus b will be equal to minus 3 and a multiplied by b will be equals to 2. So clearly we can see that we can consider a as minus 2 and b as minus 1, because their product is 2 and their sum is minus 3. So we can say the factors of x square minus 3x plus 2 will be x minus 2 and x minus 1, and hence we can write the numerator as x minus 2 multiplied by x minus 1 divided by, we have in the denominator y multiplied by x minus 2. So x minus 2 cancels out, and we get x minus 1 divided by y. So this is the reduced form, this is the simplest form of the given rational expression, and hence the correct choice is B. B is the correct choice. Okay, let's do problem number 4. The remainder obtained when t to the power 6 plus 3t square plus 10 is divided by t cube plus 1. The remainder obtained. Okay. Now, please notice that. So we are asked what will be the remainder of when we divide the polynomial t to the power 6 plus 3t square plus 10 by the polynomial t cube plus 1. It is asking the remainder. Now, if t cube plus 1 is a factor of this polynomial, then obviously there will be no remainder. The remainder will be 0. So let us see if we can now the easiest way to find what will be the remainder is by doing the long division method. So let's straight away do the long division method of this division. So the first term of the question, first term of the question, that is when we do the long division method, that is when we divide the polynomial of the degree 6 by t cube plus 1. The question, the first term of the question will be the first term of the dividend divided by the first term of the divisor. This is equal to t cube. Hence, let's start the long division method, and we have the dividend as t to the power 6 plus 3t square plus 10. Okay, so the first term of the question will be t cube. Now we multiply the first term of the question with the divisor, and we get t to the power 6 plus t to the power 3. This need to be subtracted from the dividend, and we get t to the power 6 cancels out, and we get minus t cube plus 3t square minus t cube. Minus t cube was the remainder, and we bring down the next term from the dividend and add it to the remainder. So it becomes minus t cube plus 3t square. Now becomes the next dividend. Okay. Now the next term of the question will be the first term of the dividend, that is minus t cube divided by the first term of the divisor, that is t cube, which is equal to minus 1. So minus 1 will be the next term in the question. So minus 1, and we have when we multiply minus 1 with the divisor, we get minus t cube minus 1. We subtract this from the current dividend, and we have t cube cancels out, and we get 3t square plus 1, and we then bring down the next term from the dividend, add it to the current remainder, and the remainder becomes 3t square plus 11. So this is and we cannot do further long division method because the degree of the remainder is less than the degree of the divisor. So 3t square plus 11 is the remainder when we do the division, and hence the correct choice is C. C is the correct choice. Okay, let's do problem number 5. Okay, it is asking the value of 1002 square of 1002. Now definitely we have to do this using some identity of factorization. Okay, so we know. Okay, so 100. This is 1002. So 1002 can be written as 1000 plus 2. So we can see we are having a plus b whole square. A is, you can consider as a, 1000 as a, and 2 as b. So we can use the identity, algebraic identity, that is a plus b whole square is equal to a square plus b square plus twice ab. So this will be 1000 square plus 2 square plus 2ab, that is 2 into 1000 into 2. This is equal to 1000 square means after 1 there will be 6 zeros. 6 zeros, and we have 4, and we have 2 into 1000 into 2 is 4000. So this is equal to 1 6 zeros plus 4000 and 4. So this is equal to 1004004. So this is the value, and hence 1004. Okay, so the correct choice is D. D is the correct choice. So this was an application of applying the a plus b whole square in finding the value of a square of a number. So the number was 1002. You just have to split it as a plus b conveniently, so that you can apply a plus b whole square, and the computation of a square and b square is relatively easy. Okay, let's do problem number 6. Okay, an equation is given and we have to find the value of k. The equation is 4a x square plus 8 a square x divided by 2ax. This is given to be equal to kx plus 4a. So we have to find the value of k. Okay. Now clearly we know that the left hand side is a division of two polynomials. The numerator is a polynomial. If we consider x as the variable, the numerator is a polynomial of degree 2, that is x square, and the denominator 2ax, it's a polynomial of degree 1. So we would like to simplify the left hand side polynomial, that is the division or the rational expression, in its simplest form, so that we can get a single polynomial of degree 1, because the right hand side we are having kx plus 4a, it is a polynomial of degree 1. So from the left hand side, from the numerator, we can clearly see we are having a common factor of 4ax from both the terms. So if we factor out 4ax from both the terms in the numerator, we get 4ax multiplied by x plus 2a, and we have in the denominator twice ax. This is equal to given as kx plus 4a. This implies, if you do some cancellation, 2ax will cancel 4ax with 2. So we get twice of x plus 2a is equal to kx plus 4a. This implies, if you do the product of 2 and the binomial x plus 2a, we get 2x plus 4a is equal to kx plus 4a. We can cancel out 4a, the term 4a from both sides, and we get 2x equals to kx. This implies definitely k has to be equal to 2, and hence the correct choice is B. B is the correct choice. Okay, let's do problem number 7. The question, when a polynomial is given of degree 5, where the variable is m, the quotient when the polynomial is divided by 1 plus m is the quotient. So definitely when it is asking the quotient, the 1 plus m should be a factor of the given polynomial of degree 5. Okay, so we are asked to find m to the given polynomial of degree 5 is m to the power 5 to m to the power 4 plus m cube plus m square plus twice m plus 1 we have to do the division of this polynomial by 1 plus m. So this we have to find. So this is whatever the result will be. This will be the question when the polynomial of degree 5 is divided by 1 plus m. Now, when you are asked to find the quotient of two polynomials, it is better that you factorize. If you can, you factorize both the dividend and the divisor, and then you cancel out the common factor to find the quotient. So the divisor is 1 plus m, that cannot be further factorized. It is a irreducible factor, but the polynomial of degree 5, that we can factorize further. So let's try to factorize the polynomial, the dividend, that is m to the power 5 plus twice m to the power 4 plus m cubed plus m square plus twice m plus 1. Now I can clearly see the last three terms are in the form of a plus b whole square, where a is m and b is 1. So this will be a 1 plus m whole square. Now what about the first three terms? For the first three terms, I can see that m cube is a common factor of all the terms. So if I take out m cube from all the first three terms, I get m cube multiplied by m square plus twice m plus 1. And let's express m square plus twice m plus 1 as 1 plus m whole square. So this is equal to m cube. Again we can see m square plus twice m plus 1, which is in the form of a square plus b square plus twice ab, where a is m and b is 1. So we can write it as 1 plus m whole square, and we have 1 plus m whole square. Now we see we can factor out 1 plus m whole square, and this will be equal to 1 plus m whole square multiplied by m cube plus 1. So this is the factorization of the polynomial, a given polynomial of degree 5, and hence when we divide, so this implies 1 plus m whole square multiplied by m cube plus 1 is the polynomial factorized form of the polynomial of degree 5. When we divide that by 1 plus m, what do we get? We get m cube plus 1 multiplied by 1 plus m, because the denominator 1 plus m cancels one factor of 1 plus m from in the numerator. So this is the question, and hence the correct choice is D. D is the correct choice. Okay, let's do problem number 8. It is a simplification problem. Basically, it is asking to divide a given polynomial, which is x square minus 24x plus 144 multiplied by x minus 3. We have to divide this polynomial by x square minus 15x plus 36. To do this kind of simplification, where it is a rational expression, where both the numerator and the denominator are both algebraic expressions, if we can, we should first factorize both the numerator and the denominator, and then we cancel out any common factors if we can see any common factors. So so what will be the factorization of x square minus 24x? Let's on the rough side do the factorization of x square minus 24x plus 144. Now we can clearly see by observation that plus 44 is 12 square. We have x square and 12 square. So and also we have the term minus 24x minus 24x. So we can possibly form a minus b whole square if we can express this quadratic trinomial as a square plus b square minus twice ab. So we have x square plus 12 square. We just need minus 2 into x into 12, and indeed it is equal to minus 24x. So we can express this quadratic trinomial as x minus 12 whole square. So we have x minus 12 whole square multiplied by x minus 3 divided by, let's factorize the denominator, that is x square minus 15x plus 36. So it is a quadratic trinomial. We have to find the numbers a and b such that a plus b is equal to minus 15 and ab is equal to 36. Now what can a and b be? 36 is equal to 9 and 4 will not help because 9 plus 4 is 13. 18 and 2 will not help because 18 minus 2 is 16. 3 and 12. Okay, 3 and 12 will help. 12 multiplied by 3, its sum is 15. So we can say that minus 36, we can write it as minus 12 into minus 3. Now we can see that minus 12 into minus 3 is 36, and also minus 12 plus minus 3 is minus 15. So x square minus 15x plus 36 can be factorized as x minus 12 multiplied by x minus 3. So x minus 3 cancels out, and x minus 12 cancels 1 x minus 12 in the numerator, and hence the result is x minus 12. So the correct choice is D. D is the correct choice. Okay, let's do problem number 9. Okay, and again an equation is given. The equation is p to the power twice x minus 11 p to the power x minus 26 is equal to, given as p to the power mx plus a multiplied by p to the power mx plus b. Then the value of we have to find the value of minus 1 to the power m multiplied by a plus b. So we have to find a, b and m from this given equation. Now in the given equation, the right hand side we can see it is of the form kind of a variable. Now you can consider p to the power mx plus a multiplied by p to the power mx plus b. Okay, now in this polynomial, now this might look a little weird because in the power you have x. In the power you have x. Normally x is considered as variable, but in this problem we have x in the power, but it should not be a problem. It should not we can even apply now consider, please observe that p to the power 2x is nothing but p to the power x square of p to the power x, and we have 11 px minus 26. So it is kind of the form a square, where a is p to the power x and minus 11a minus 26. So for the time being, just mentally think p to the power x. You can also do it this way. Let p to the power x be equal to, give it some other variable name. Consider this as some variable, let's say y, for the sake of easiness of the calculation. So if you assume that p to the power x is equals to y, then we are just concentrating on the left hand side of the equation. So the LHS will become y square minus 11p minus 26. Now we can see it is of the form kind of a quadratic trinomial in y, even though we know that y is equal to p to the power x. Now we can clearly factorize, hope we can factorize this, y square minus 11p minus 26. So we have to find a and b such that a plus b is equal to minus 11 and ab is equal to minus 26. Okay, now minus 26 is minus 2 multiplied by 13, and we can clearly 13. So 13 minus 2 will not help. 13 plus minus 2 will not help because it will be 11. We need negative 11. So we can consider minus 26 as 2 multiplied by minus 13. Now their product will be minus 26, and as well as their sum, that is minus 13 plus 2 is minus 11. So we can consider, so the factorization of y square minus 11p minus 26 will be y minus 13 multiplied by y plus 2. Okay, so we have factorized. Now you can substitute the value of y. So this is equal to, we assumed y to be p to the power x. So this becomes, the left hand side of the equation becomes p to the power x minus 13 multiplied by p to the power x plus 2 is equal to, the right hand side is p to the power mx plus a multiplied by p to the power mx plus b. Now if you compare the two factors, you can clearly, if you compare both the factors on the LHS and RHS, you can clearly see, we can clearly say that m has to be equal to 1, because on the left hand side we have p to the power x. On the left hand side we have two factors and in both the factors we are having p to the power x and some constant. On the right hand side we are having also two factors, where each factors are having p to the power mx. So clearly we can, by common sense, we can say that the m has to be equal to 1. So we get m equals to 1. Okay, now we can say that either a and b has to be minus 13 and 2. Now a can be minus 13 and b can be 2, or a can be 2 or b can be minus 13. But to solve this problem, it should not matter, because we just need the value of a plus b. We just need the value of a plus b. So definitely we can say that a plus b has to be equal to minus 13 plus 2. This is equal to minus 11. So we got m equals to 1 and a plus b equals to minus 11. So this implies we are asked to find the value of minus 1 to the power m multiplied by a plus b. So this becomes equals to minus 1 to the power 1 multiplied by minus 11. So this is equal to minus 1 to the power 1 is minus 1 and multiplied by minus 11, which is equal to 11. So the correct choice is C. C is the correct choice. Okay, let's do problem number 10. The number of irreducible factors of the expression division is given. The expression is given is x to the power 4, y to the power 4, z to the power 4 minus 81 divided by x by z minus 3. It is asking to find the number of irreducible factors of the expression. Okay. So first we have to find this expression, that is we have to divide the expression in the numerator by the expression in the denominator. That is possibly we have to factorize the numerator and see if there is any common factors. If we can cancel out the denominator is an irreducible factor, because x by z minus 3 cannot be further factorized. So any algebraic expression which cannot be further factorized is known as an irreducible factor. So we have to see whether x by z minus 3 is a factor of the expression in the numerator, and then we have to cancel that out, and the final question, the final expression we have to see what are the remaining factors. So we have to find the number of factors of these of the simplified version of this expression. So first we have to factorize the numerator. Now we can see the numerator 81 we can see is 9 square, and also we can say x to the power 4, y to the power 4 and z to the power 4 can be written as x square, y square, z square and whole square, and we have minus 81, 81 is 9 square. We have x, y, z minus 3. Now the numerator is in the form of a square minus b square, and we apply the identity a square minus b square is equal to a minus b multiplied by a plus b. So we get x square, y square, z square minus 9 multiplied by x square, y square, z square plus 9 divided by x, y, z minus 3. Now we can see that this term, this factor in the numerator is also can be further factorized because it is of the form a square minus b square. That is, it is x, y, z square minus 3 square, and we have x square, y square, z square plus 9 divided by x, y, z minus 3. Now this part, this factor, when further factorized, it is in the form a square minus b square. So if we factorize that, it will be x, y, z minus 3 multiplied by x, y, z plus 3, and we have x square, y square, z square plus 9 divided by x, y, z minus 3. So we can cancel out x, y, z minus 3, cancel out from both the numerator and the denominator, and we are left with x, y, z plus 3 multiplied by x square, y square, z square plus 9. So clearly we can see there are two factors. There are two factors of these are irreducible factors because the factor x, y, z plus 3 cannot be further factorized into two or more factors. Similarly, the factor x square, y square, z square plus 9 cannot be further factorized into two or more factors. Hence, the number of factors of the given expression will be 2. So, the correct choice is B. B is the correct choice. Okay, now back to the question number 1, which I could not solve. Let's see if we can do something. Okay. It is saying that if the two polynomials are given are divided by x minus 3, then the remainder in each case is the same. Then the value of p is. Okay. Now we cannot perform a long division method. We cannot divide the two polynomials by x minus 3 because we don't know p. So we cannot really proceed with the long division method. So one concept is that, as I already discussed, that a polynomial p is that a polynomial p will be divisible by x plus a if the value of the polynomial p at x equals to minus a becomes 0, and also if x plus a does not perfectly divide the polynomial p, then the remainder when p is divided by x plus a will be the value of the polynomial at x equals to minus a. Now, I hope this is the concept. I am not really sure whether I am saying it correctly or not, but definitely if a polynomial p is divisible by x plus a, then the value of the polynomial at x equals to minus a will be 0. That is for sure. But if x plus a is not a divisor, that is, if p is not divisible by x plus a, then whether the remainder when p is divided by x plus a will be the value of p at x equals to minus a. This concept I will have to check. I am not I'm not really that sure. So I will leave this question. I will try to solve this offline and come up with a solution in the next video, in the next set. I'm sorry I could not solve the first problem. So I hope this video was beneficial. This set of 10 problems where I could not solve one. The first one will give you a good practice of your understanding of the chapter concepts on factorization, and also will uh, evaluate your understanding of the concepts. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So please stay tuned for more this kind of 10 good problems from the chapter factorization, as I will keep on making this kind of videos uh, on regular basis. And as and when the new chapters are completed in the other playlist, that is CBSE Maths 8 RS Agarwal, I will prepare 10 good problems and solve in this playlist, that is Maths 8 HOT. So thanks for watching, and until the next video, take care and bye.